This video is on section 1.4 notes, percent problems. So in the last section, we started learning a little bit about percentages or percents, and now we're going to go through and actually do some problems with that. So first, I put the definition of percent and percentage so you can compare them. To be honest, most people kind of use them interchangeably and think of them as synonyms, even though technically they're a little bit different. So a percent is a part of a whole expressed as a fraction with a denominator of 100, while percentage is the concept of expressing a part of a whole as a fraction of 100. A percent is symbolized with a sign percentage. The specific unit of measurement itself. Honestly, using these interchangeably is not going to hurt you at all in this class. So I just put them both up there so you can see them. All right, all percent problems involve three quantities. So we're going to express these problems as a ratio using two fractions, but one part of one of the fractions is always going to be 100 because these are percent problems. So here's the three different parts that are going to be something that we can change each time. The first is B, it's the base or the whole or total amount. It's our standard that's used for comparison. So that's right here. P is the part that's being compared to the base. It's the smaller portion. And then R is the rate or the percent number. And that's what's going to go above the 100. So you can think of it as something is of whatever total and then percentage out of 100. And this looks weird right now, but it's actually really helpful. So we've got the part out of the whole thing equals some percentage out of 100. All right, so we're going to translate the percent statement. 3 is 75% of 4. So it says is, so that's the 3. 3 is, so 3 goes on top. 75%, so the percent goes over here, 75%. Of 4, so the of goes right there. Of 4, and then this one is always 100. So 3/4 is the same as 75 over 100, and we can double check that. We can just make sure that these are the same. And they are. 0.75, 0.75. All right, the next question says, what is 30% of 50? So what is, that's what we're solving for. So the is what we're going to solve. So I'm going to put P there. What is 30% of 50? So 30%, we know that this part is always 100. So 30% over 100. And then of 50, the of is 50. And then we can go ahead and cross multiply. So I've got P times 100 equals 50 times 30. So 100P equals 1500. And I'll divide by 100. And I get 15. So the part is 15. 15 out of 50 is the same as 30 out of 100. And I can double check it. 15 out of 50 is the same as 30 out of 100. And that is true. Okay. Find 8.5% of 160. Okay, so 8.5%. So 8.5 out of 100, because it's always out of 100. So we've got our percentage over 100. They didn't say anything about is, so that's what I'm going to be solving for. They said of 160, so the of is the 160. All right, and now I'm going to go ahead and cross multiply. So P times 100 is 160 times 8.5. So I'll go ahead and divide by 100. $13.6. So 13.6 out of 160 is the same as 8.5 out of 100. and that's true. Okay. What percent of 8? What percent of 8? So the percentage is what we're trying to find. The percentage rate out of 100. What percent of 8, so the of goes down here, is 5? The is goes up here. So 8 times r equals 5 times 100. And then I'll divide by 8. So the percentage is 62.5%. Okay. Find what percent. So always over 100, the percent over 100, and then we're going to do is over of. So 990 is of $18. And then we can cross multiply. So 18 times r, 990 times 100. So 990 is 55% of 18. Okay, 8.7 is 30% of what number? So 30%, 100. We put the is on top, the of on the bottom. So 8.7 is of what number? This is the B. The base or the whole or the total amount. So B times 30 is 8.7 times 100. $870. $29. So 8.7 out of 29 is 30%. 8.7 is 30% of 29. Find a distance such that 12.5% of it is 26 1/4. Okay, so 12.5% is 26 1/4 is, and then we're going to do of whatever that whole distance is. So I'll cross multiply B times 12.5 equals 26 1/4 times 100. I'm going to divide that by 12.5 to 10. And it was feet. Okay, so we're going to be doing the same thing, but now we're working with word problems. So it says, a moderately active adult weighing 175 pounds needs to consume 2,800 calories per day in order to maintain his or her weight. a nutritionist recommends that no more than 30% of those calories should come from fat. What is the maximum number of calories per day that should come from fat? So there's the percentage. So I know that I'm going to have something equals 30% over 100. And I have is over of. I know I have to have the part out of the whole. So here, what is the maximum number of calories? That's what I'm trying to solve for, is what part? What is the 30%? And so the whole thing is going to be the calories, the 2,800 calories. So one thing that could kind of help you as you do this problem is that you'll notice, just like all of the ratio problems that we've been doing this whole chapter, that these ratios are set up to have the same units. So here we have percent over percent, right? 30% over 100%. And then we're finding the number of calories divided by the total number of calories. So these are both in terms of calories. So that's kind of what clued me in a little bit, that I shouldn't use the 175 because that's pounds, but I'm trying to find calories. So that could be something that could be helpful if you're solving this and you have extra numbers in the problem that they threw in there to see if you could figure out what you were doing or not. I'm going to go ahead and cross multiply so that I can solve this. So P times 100 is 2,800 times 30. So 100 P is 84,000. Divide by 100. And the part that we can have from fat calories, 2,800 calories in a day, and 840 of those should be from fat. Okay. A builder told his crew that the site preparation and foundation work on a house would represent about 5% of the total building time. I'm just going to write this down. 5% over 100. Okay. If it took the crew members 21 days to do this preliminary work, how long will the entire construction process take? So I don't see the words is and of. So I'm going to have to think of which one should be the part and which one should be the whole. So it says how long will the entire construction process take, and then 21 days to do preliminary work. So 21 days for preliminary work sounds like a part, and then entire process sounds like the whole. So I'm going to say 21 for preliminary, and then I'm going to put B for the base or the whole or the total amount. And then I'm going to go ahead and just solve this and cross multiply. So B times 5 equals 21 times 100. $2,100. So 420 days is how long the whole process should take. Okay, and then one last problem. Says 12 milliliters of pure acetic acid are mixed with 38 milliliters of water. Calculate the percent concentration of the resulting solution. Okay, so R is what we're calculating, and they didn't say is or of, so I have to think about what is the part and what is the whole. So calculate the percent concentration of the resulting solution. Okay, so the acid, this is the part. The acid is mixed with water, so the part is 12, and then the whole is all of it. So the whole is not 38 because that's not all of it. The whole is going to be 12 and 38 added together. That's all of it, all of the liquid. So part of the liquid that's acetic acid, and then all of the liquid. So acid, and then all liquid. So 12 and 38 gives you 50. Okay, so there's the part out of the whole, and I'll go ahead and cross multiply. So 50 times R equals 12 times 100. And our percentage is 24%. So this liquid we have is a mixture that's 24% acid, or that's the concentration of acid in the solution.